all celestial bodies, remaining all celestial bodies together constitutes or constitutes 0.2 percentage of 0.2 percentage of. So remaining all celestial bodies together constitutes 0.2 percentage of total mass of solar system, right? Very important point. So sun alone constitutes 99.8 percentage and remaining all celestial bodies together constitutes 0.2 percentage of the mass. So that's why we call most massive object, most massive meaning which is very big, very big. And if you take the mass of the sun, listen carefully, mass of sun, so here this is in percentage, but if you take in the in the scalar quantity, the mass of sun, just listen, so mass of sun will write m sun, mass of sun is almost 1.998 into 10 to the power of 30 kg, right? So here 1.998.10 to the power of 30 kg, it is the mass of the sun, and that will write approximately 2 into 10 to the power of 30 kg. There no need to remember all the numbers, but you should remember approximate numbers. So 2 into 10 to the power of 30. So 1.998, there no need to remember. Just remember 2 into 10 to the power of 30 kg. It is the mass of, it's a mass of sun. And mass of sun, remember, mass of sun, it is almost 3 lakhs times the mass of the earth. Whatever earth is having the mass, with respect to that, the mass of the sun is 3 lakhs times more than the mass of the earth. Just listen, here mass of earth is around 5.97 into 10 to the power of 24 kg, right? 24 kg. So mass of earth is 5.97 to 10 to the power of 24 kg. It's a mass of the earth. And mass of sun, it is approximately, equal to the 3 lakhs times the mass of 3 lakhs times you write multiply, right? Mass of earth, very important point. So here the mass of sun, it is 3 lakhs times the mass of the earth. You got this point? So that much it is massive. It is very, very big. How many times it is bigger than the earth? Almost 3 lakhs times it is bigger, right? So 3 lakhs times the mass of the earth. And what is the mass of the earth? 5.97 to 10 to the power of 24 kg, right? Again, there is no need to by heart the numbers, but this relation is very important here. So they can ask the question from this relation, right? This is very important. Mass of sun is almost approximately 3 lakhs times the mass of the earth. Next point. So your mass wise, which is more massive? Answer is sun. And which is the most massive planet in our solar system? Most massive planet, not star. Most massive planet, Jupiter, right? Most massive. So, but most massive object is sun, or most massive star is also sun. Sun is the only star in our solar system, right? Next point. So your next point, write down. So your gravity of the sun, or gravity on the surface of the sun. Gravity on the surface of the sun. Gravity on the surface of the sun. Right? So first you should know what is the gravity value on the earth surface. What is the gravity on the earth surface? 9.8 meter per second square. Listen first. So here this is the, suppose if you take this is the equator, 0 degree latitude, equator, right? Equator, and it is the north pole and it is the south pole, right? North pole and south pole. So which part of the earth having more gravity? Which part of the earth having more gravity? Or entire earth having same gravity? Entire earth having same gravity or different gravity? Same. Different. Okay, listen. So different part of the earth having different value of gravity. So gravity will not remain same. Yesterday I said the value of the gravity will increase or decrease with respect to mass of the object. If the mass of the object increases, then definitely gravity will increase, right? But remember here, when you take the center of the earth, so to the center of the earth, so when you compare the poles and equator, so poles are close to the center of the earth as compared to equator. The center of the earth is close to the poles as compared to the equator. I think globe is there or not? Okay. So please remember, when you compare the earth is there. Just please bring the globe. So center of the earth is close to the poles and equator is away from the center of the earth. Just listen, yesterday also we have discussed, if there are two objects, it is M1 and it is M2, right? Or you can say it is M1 and it is M2, M1 and M2, right? Okay, listen. So here, we'll listen later. First, just let me explain this concept. So this is M1 and this is M2. And M1 meaning the larger object, and this larger object will attract the smaller object with a gravitational force equal to M1 into M2, mass of the object, and divided by square of the distance between them, right? And if the distance increases, the gravitational force decreases. With increasing distance, the gravitational force decreases. For example, if suppose it is one object and this is another object, right? And this is A and this is B object, right? And object B is very far. For example, if suppose distance is 100 kilometers, just I am taking example, 100 kilometer, and this distance is around 20 kilometer, then object M1 or object, if suppose this is C object, this is a D object, and this object C will attract the D object with more gravity because they are very close. And this object A and object B, they are very far. That's why gravitational attraction or the force will be less here. So that's why A object will attract B with lesser force, lesser gravitational force, because that object is very far. That's the gravitational pull will be less. And the gravitational pull will be more because the gravitational force of attraction is more, because they are close, they are very close. As there are more close, they will attract more object, right? So that's why please remember here. So here when we compare the poles and equator. So this equator part is a bulged part. It's a bulged part, and the poles part is a flat. So it is little bit flat, but it is a bulged part. It's a bulged part that we call the geoid. So earth we call the geoid, right? So because this part is bulged part, that's why we call it geoid. The earth surface is geoid shape, right? So it's not completely circular, not completely spherical. So geoid shape, meaning bulged at the equator and flat at the poles. So it's a flat at the poles. Flat meaning that part is close to the center. Center will be the inside the earth, right? That center is close to the poles, and that's why as the distance is less, so there will be more gravity at the poles. And equator is away from the center, means the distance between the center of the earth and the equator is more, and that the distance is more, the gravitational force of attraction is less, right? That's why the G value will be less at the equator. So at equator the G value is less. The G value is 9.79 meter per second square, and the G value at poles, it is more 9.81 meter per second square. The gravity value is more near poles, and the gravity value is less at the equator. And if you take the average, gravity value, average G, so that is 9.81 plus 9.79 divided by 2. So it comes 9.8. And in most of the books this value is written. So because it's an average value, remember it's an average value, and that's why students will think that the 9.8 is the same everywhere. It is not same everywhere, right? It is the average value. It's the average value. Maximum value will found at poles and minimum value found at equator. Why minimum value at equator? Because equator is little bit away from the center of the earth, and poles are close to the center of the earth. And as the distance is less, there will be more gravity. If distance is more, lesser gravity. You got this point? And average value of gravity on the earth surface is 9.8 meter per second square, right? So if you get the question, just listen carefully. So when you compare equator and poles, in which place, in which region mass of the object remains more? At equator, at poles, the mass of the object remains more, or mass remains same. If you take the mass of any object, that mass of the object, it remains same or it will change at equator and at poles. Mass of the object. If suppose if you go to the equator, if you are standing on the equator and immediately you take the flight and you go to the poles, and your mass will change or your mass will remain same? It will change, right? How come the mass will change? Yesterday I will give the example. So if you go to the airport, now you are here, and if you go to the airport here, within 1 hour your mass will change. It will not change, right? It's a scalar quantity. Yesterday only I have discussed. Mass is the scalar quantity, it will not change immediately, right? So your mass remains same, but the weight will change. Why weight will change? So because weight is depending on the value of gravity. So because your W is equal to m into z, and the m is a scalar quantity, almost remains same, but the g will change, and with change in the g, the weight will change. And listen carefully. If suppose if any object x, its mass is 100 kg. Its mass is 100 kg. Listen carefully. Its mass is 100 kg. So its weight will be the mass of the object x will be 100 into 9.81. So it is 981 at poles, and at equator, listen, m is equal to your weight is equal to m into z, and mass remains same, it will not change, but the gravity value is different here, 9.79. That's why it is 979. So that's a weight of the object is 979 at equator, weight of the object is 981 at the poles. That's why weight will change, but the mass will not change. Mass remains same, and the weight will change because change in gravity will change the weight of the object, because weight is the product of the mass and gravity value. But the mass is the scalar quantity, it will not change. You got this point? So if you go to the poles, your weight will increase, not the mass. Mass remains same, only the weight will change, right? Because the gravity value is different at different places. This is a very important point. So your gravity is more at the poles. That's why weight also remains more. And gravity value is less at equator. That's why weight of the object also remains less at the equator, right? Let's start on a few points, 2-3 lines. Write down. Next important point. Average value of gravity on the earth surface. Average value of gravity on the earth surface. Average value of gravity on the earth surface is 9.8 meter per second square. 9.8 meter per second square. 9.8 meter per second square. Full stop. Value of gravity remains more. Value of gravity remains more at poles. Value of gravity remains more at poles. Value of gravity remains more at poles. At poles. That is 9.81 meter per second square. That is 9.81 meter per second square. 9.81 meter per second square. And it remains lesser at equator. It remains lesser at equator. That is 9.79 meter per second square. That is 9.79 meter per second square, right? Meter per second square. 9.79 meter per second square, right? Full stop. Next, another point. Just listen here. So your mass of the object will remain same irrespective of the value of the gravity, but weight of the object will change with respect to change in the value of the gravity. Write down that one line. Write down. Mass of any object remains same. Mass of any object remains same. Irrespective of gravity. But weight of an object, this is very important point. Weight of an object will change. Weight of an object will change with change in gravity value. With change in gravity value. Right? With change in gravity value. Full stop. Listen, I will give an example. Suppose this is the earth, right? First it is sun, Earth and Moon. There are three objects. One is Moon, it is Earth, it is Sun. And there is one object called object X. It is one object X, and mass of X is 100 kg. 100 kg. So your mass of object X is 100 kg, right? So if mass of this object X, it remains maximum on the surface of Sun or on the surface of Earth or on the surface of Moon, or it remains same. Mass of the object, it remains same or it will change with respect to Sun, Moon and Earth? Remains same. Okay, listen. So here object meaning, or you can say for example astronomer, right? Astronomer, for example Kalpana Chawla, or recently, right, Sunita Williams, right? So in they take an astronomer, so here their mass is 100 kg. So their mass will remain same irrespective of gravity, I said very clearly. That's why their mass remains same on the surface of Moon also, on the surface of the Sun also, on the surface of the Earth also. But their value of their weight will change. Weight will change. So because why the weight will change? Because of the gravity. The gravity is different. And when you compare these three objects, so which object or which celestial body having maximum gravitational force? Which have maximum gravitational force? Moon or Sun or Earth? Which have maximum gravitational force? Sun. Why? Mass is more, object is larger one. So just listen clearly, the object those are larger in size, they will have more gravitational force of attraction. So your Moon, Sun is the larger one. That's why it will have more gravitational force of attraction. And already we know that the G value is 9.8. I am talking average value, meter per second square. And the value of G, listen carefully, the value of G on the surface of Moon, it is 1/6 of the value of G on the Earth surface. Whatever value is there on the Earth surface, listen carefully. So the gravity value on the Earth surface. So 1/6 of the gravity value on the Earth surface. And we know very well the gravity, just listen, 1/6 into Earth, the gravity value on the Earth surface is 9.8 meter per second square, right? And if you divide it, so you will get 1.62 meter per second square. Very, very important point. So G Moon, gravity value on the Moon, so it is 1.62 meter per second square. And the gravity value on Sun, it is 28 times the gravity value on the Earth surface. Because Sun is larger than the Earth, and that's why gravity value on the Sun is 28 times more than the gravity value on the Earth surface. And we know that here is a 28, and gravity value on the Earth is 9.8 meter per second square, right? And here 28 into 9.8, almost it comes to 274 meter per second square, right? 274 meter per second square. It's a gravity value on the Sun. And so this is most important information, right? Please remember, the gravity value on the Sun is 274 meter per second square. On Earth surface 9.8 meter per second square. On the Moon surface it is 1.62 meter per second square, right? And they will ask the question, and they never ask these numbers. UPSC never ask the numbers, but they can ask the question. So arrange the following. Listen first. Arrange the following objects in decreasing order as per their gravity. Then your answer is first G Sun, which is greater than G Earth, which is greater than G Moon. They will ask this equation. So arrange the following objects in decreasing order or increasing order as per the gravity value, right? So G Sun, it is 274 meter per second square, which is greater than 9.8 meter per second square, which is greater than 1.62 meter per second square. They will ask this equation in the exam. So they will ask the question in the exam, this equation they can ask, right? But they will not ask directly values. What is the value of gravity on Earth? They never ask, right? But they will ask the question, arrange the following objects in decreasing order or increasing order as per the gravity value. Most important equation, put here a double star. most important. Double star meaning very important for your upcoming exam, very important. So like that you should knowing the concept. You should not by heart the numbers only. If you by heart the numbers, so you will not clear the UPSC civil services. You can clear your railway exam or some SSC exam. So to clear UPSC civil services, you should be perfect in the concept, and you should have the concept clarity. So concept clarity will help you a lot, right? And if you are focusing only on the facts, it's very difficult to clear the PT. And facts also very essential. So if you mention the facts in the mains answer, you will get very good marks. And without facts, you will not get good marks again in the mains. So in mains, you need the concept plus some facts. And without fact, you can't justify your answer. For example, if you are discussing the question, if you are discussing the answer like about farmer suicide, right? So if you get the question in the mains, discuss the causes for the increasing farmer suicide in India. So you will write all the causes. You will highlight the important cause is the loan, because the loan on the farmers are increasing. And there are two types of loan. One is organized loan and unorganized loan. Organized loan meaning the loan taken by the banks, government banks, we call the organized loan. And the loans taken by the money lenders, we call the unorganized loan. And the loans, when the farmers take the loan from the money lenders, the farmer, they have to pay the more interest amount, because the money lenders will give the loan at a higher rate of interest, and the government banks will give the loan at a very lower rate of interest. So for example, you might be knowing the general things in the villages, in village areas, the loan will be given at 3 rupees, generally 3 rupees, 4 rupees, 5 rupees, right? So if suppose if you take the loan, 1 lakh loan, listen, if you take 1 lakh loan at a interest rate of 3 rupees, right, at a interest rate of 3 rupees for 1 year. So what would be the interest amount after 1 year? If you take 1 lakh rupees at a interest rate of 3 rupees, not 3%, 3 rupees, if you take the loan at 3 rupees interest rate, right, and if you are taking principal amount of 1 lakh, after 1 year, what would be the interest amount? Yes, we will tell. Yes, very good. 36,000 rupees, because every month it is 3,000 rupees. 3,000 rupees. 3 rupees. 3 rupees for 1 lakh or 100 rupees. Then if you calculate, it will become 3,000 per month. And in 1 year we are having 12 months. 12 into 3,000, almost 36,000. Please remember, if the farmers will take 1 lakh loan, they have to pay 36,000 rupees as the interest amount. And just imagine a farmer, a poor farmer, who is bringing 1 lakh rupees loan, and if that in that 1 lakh, if entire amount he invests in the agriculture land, even he can't get more than 20,000 rupees as a profit. If the farmer investing 1 lakh rupees for leveling the land and to purchase some motors or some pipelines, if you invest 1 lakh also, maximum you will get 20 to 30,000 rupees in this profit. And if you get 30,000 rupees profit, that amount is not sufficient to clear the interest amount itself, right? So please remember, if the farmer invests 1 lakh and he gets 30,000 rupees as the profit, and after working 1 year, the entire profit is giving as he is paying only as the interest amount. Just what about his survival? And that is the main problem. And whenever so some marriages comes in the farmers' families, they have to give the dowry also, and most of the farmers in India, they are the small and poor farmers, and they are the marginal farmers. So they are holding the agriculture land less than 2 hectares of the land, right? Around 60 to 65% of the Indian farmers are the poor farmers, right? And they are facing lot of problems. And whenever the marriages, like marriage of their daughters comes, right, and they have to give the dowry, it's a very big problem in our country, right? So because here the dowry is mandatory, because it's illegal in India. Taking dowry is also illegal, giving dowry also illegal, but still the people will give the dowry and take the dowries, right? So because, and most of the people, if you are an IAS officer, you will demand 1 crore dowry, because I am an IAS officer, I need more dowry, right? Please imagine, when we talk about, because you are a well-educated person, and if you talk about the dowry, so because there is no any human values. So dowry meaning, earlier they used to give in the form of gift, but now it became mandatory nowadays, right? So earlier it was one kind of gift, right? But now it became mandatory. In villages, now, especially in Karnataka, Andhra and Telangana, so this is deep rooted, and it is mandatory. And most of the marriages will break down because of the dowries only, because you are not giving the dowry, that's why marriage cancel, right? So because here we are comparing that girl with the money, right? We create the bride that we are comparing with the money. So because they are also having the human values, right? They are also having the respect, but we are comparing with the money, right, which is incorrect, which is illegal according to me, right. And in India also, giving and taking dowry is not legal, please remember. And when you become educated and when your power increases, so please don't demand for the dowry, right. So because the girl which is coming to you by respecting, so because till 20-25 years, so they are completely staying with the parents, and after leaving parents they are coming to your family, right. They are sacrificing each and everything. Again they have to give dowry, meaning it thinks that there is no humanity as per my knowledge, right. So here please remember, so when it comes to humanity, at least my students, right, please don't take the dowry, right, when it comes to, because most of you are going to marriage, right. So please don't take the dowry, because you will feel very happy in your life, at least I could not take the dowry, right, and I am following some good principles in my life, like that, right, and I followed, I implemented also, right. So that's why at least you people, if you follow it, so definitely, so you will feel proud about your life, right. So because you are respecting a girl, because when the girl leaves her parents and when they are coming to your family, they are sacrificing many things, right, and they are coming to you. That's why please, so right, it's to all online students and offline students. So if you follow these principles, you will get very good marks in the ethics paper, right. We are doing these things, and again we are expecting to get good marks in the ethics. It's not possible. First you have to follow it, and that human values we should have first. And if you are having the human values, then definitely get the good marks in the ethics paper. So ethics paper meaning is not like history paper, right. So ethics paper is completely depending on your human values. If you are having the good human values, so you can write in a better way and definitely get the very good marks. So to get good marks in ethics paper is, so it depends on your personalities, or it depends on your human values, right, along with some readings also, right, around some, you need some readings also, like there are many books also to read for ethics, but along with the books, the only books knowledge will be not sufficient to get good marks. Along with the books knowledge, you need some your human values also. You got this point? Okay, come to the point here. So here we are discussing this one, right, the gravity, and among these three, the largest object is sun and the smallest object is moon. And in decreasing order, they can ask the question in the increasing order also. Have you taken this equation? Right? Okay, good point. Next one, write down. So this is about gravity. Please remember, sun having maximum gravity, and that's why it holding most of the objects. Many objects are revolving around the sun because it having more gravity, 274 meter per second square. And earth having only one object, that is moon. Only moon is revolving around the earth because earth having lesser gravity. So had earth having more gravity, it would have having more objects surrounding to its orbit. But earth is very small with respect to sun, and that's why only moon is revolving around the earth. If you take Jupiter, around 95 objects that we call natural satellites, 95 natural satellites are revolving around the Jupiter because Jupiter is larger than the earth, and that's why it's having more gravity. That's why many objects, it is pulling many objects towards its center, and that's why many objects are revolving around the Jupiter also. And 8 planets are revolving around the sun because sun pulling those objects because of its more gravity. So like that you should know the concept, right? So when it comes to gravity, so here mass is very important, or the size of the object is very important. Larger objects will have more gravity, smaller object will have lesser gravity, right? Sun having more gravity, moon having lesser gravity because moon is very small, sun is very big, right? So this is about the gravity value. And next point, just I will take the doubts of any online student, just 1 minute. Sun has more gravity, okay, good. Okay, nice. Next point, so just write down. So we are discussing here gravity and mass, and one more point, just density of the sun. Write down density of the sun. Density of the sun, right? Density of the sun. So your density. So density, it is the ratio of mass divided by volume. Mass divided by volume. So mass measured in gram, then volume centimeter cube. And if mass measured in kg, then volume measured in meter cube, right? So your unit of density, it is gram per centimeter cube or kg per meter cube. So density is measured in 2 units, gram per centimeter cube or kg per meter cube. So density is equal to density measured in gram per centimeter cube or kg per meter cube, right? Okay. So what is the density of water? Density of water. So density of water, it is 1000, almost 1000 kg per meter cube or 1 gram per centimeter cube. So 1000 kg per meter cube or 1 gram per centimeter cube. Listen, how this value came, just I will explain, just listen. So 1000 kg per meter cube is equal to 1 gram per. So you can write like this, 1000, just listen, 1000 kg per meter cube is equal to 1 gram per centimeter cube. 1 gram per centimeter cube, right? 1 gram per centimeter cube. So your 1000 kg per meter cube is equal to 1 gram per centimeter cube. Listen here, 1000. So your kg meaning 1000 grams, right? Divided by, and you know that meter, 1 meter is equal to 100 centimeters, and this is cube, meter cube. So your 1 meter is equal to 100 centimeters and it's cube, right? So just listen. So your 1000 into 1000 gram divided by, so 100 cube meaning 100 into 100 into 100, right? And here 60 in the denominator and 60 in the numerator will get cancel, and here it is centimeter cube, right? It is centimeter cube. So here, so 1 into 1 is 1, and 1 into 1 into 1 is also 1, and 1 divided by 1 is also 1, right? And that is gram per centimeter cube, right? So here 1000 kg per meter cube is equal to 1 gram per centimeter cube. LHS is equal to RHS, right? So here 1 gram, both are same. In exam they will confuse by giving the units. So here what is the density of the water? 1000 kg per meter cube, or in gram per centimeter cube it is 1 gram per centimeter cube, right? Very important point. So your density of water is 1 gram per centimeter cube or 1000 kg per meter cube. What is the density of the earth? Okay, listen. So you have taken this point. Next one, listen. So density of earth. So density of earth is 5.51 gram per centimeter cube, or it is 5500 kg per meter cube. Both are same. So in exam, just to confuse, they will give different units, and the students will get confused. Okay, they will read 5.51. In exam, they will ask 5510. They will become panic. So how come these values came karke, right? Just the units are different. With change in unit, the value also will change. For example, so what is your height in centimeters? Yes, very good. 172 centimeters. In meters? Meters. It is in feet. You are saying that is in feet. 5 point something. That is feet. In meters? Yes, very good. 1.72, because listen carefully. So here 1 meter is equal to 100 centimeter, right? And so 1 meter is equal to 100 centimeter, and 172 meter. So 172 centimeter is, you have to divide by 100. You will get 1.72 meters, right? 172 meter is nothing but 1.72 meters. Here your values are changing because of changing the units. You got a point? So in centimeters you are saying 172 centimeters. In meters it is 1.72. In feet it is 5.7 something, right? So that's why 5.9. The values will change. But your actual height will not change. Please get to the my point. Your actual height will not change, but the values will change with change in the unit. But the actual value will not change. You got the point? The actual density will not change. Only the values will change with change in the units. So it is 5.51 gram per centimeter cube, 5510 kg per meter cube. This is the density of earth. Now, density of sun. And density of sun, it is 1.4 times the density of water. Right? So density of sun, it is 1.4 times the density of water, and density of water is already we know that 1 gram per centimeter cube, and 1.4 into 1, it is 1.4 only, 1.4 gram per centimeter cube, and this is the density of the sun. Very important point. So your density of the sun, it is lesser than the density of the earth, and that's why they will ask this question. Arrange the following objects in decreasing order as per the density. So density of the earth is greater than density of sun, and density of sun is greater than density of water. And density of earth, it is 5.51 gram per centimeter cube. So it is greater than density of sun, that is 1.4 gram per centimeter cube, and which is greater than 1 gram per centimeter cube. And this equation is important for your prelims exam. They will not ask the values, but this equation they will ask. So arrange the following in decreasing order, arrange the following in increasing order, right? So equation is most important. Put here a double star for this equation. And if you know the values, then only you can give this equation, right? Decreasing order, increasing order. So here in decreasing order, so it is d earth first, d earth, right? D earth, and then d sun and d water. D meaning density of earth greater than density of sun, and density of sun is greater than density of water, right? Okay, next point. So please remember these three important points. One is density, mass, and gravity. So this is about sun. Now put the heading, next heading, that is very important topic for your mains also. Put the heading structure of the sun. And all these are the composition of the sun, composition, density, mass, they comes under composition of the sun. Now structure of the sun. Very important topic for your mains also, prelims also. Structure of the sun. Okay, and this is repeatedly asked questions in different competitive exams. Structure of the sun, structure of the earth, structure of the atmosphere. So whenever you listen the term structure, listen carefully. So whenever there are two important terms. One is the composition and structure. Listen. So they can ask the question. So like, just listen first. So discuss this composition and structure of the earth. They can ask the question, discuss the composition and structure of the atmosphere, and discuss the composition and structure of the sun. And like that they can ask any question. Discuss this composition and structure. When they ask the question structure, composition meaning you have to talk about the materials and other related parameters like density, right? Density and this one gravity, right? And some its composed material or from which material it is formed, that we call the composition. And structure meaning you have to explain about the layers. So when you get the question structure, you have to explain about the layers. For example, so structure of the earth meaning you have to talk about the layers. So layers, for example, earth having three layers: central core layer, mantle, and crust. So core, mantle, and crust, this is the structure of the earth. And if they ask the question structure of the atmosphere, then troposphere, stratosphere, mesosphere, ionosphere, exosphere, right? Tropo, strato, meso, iono, exo. So these are the layers of the atmosphere. That also we call structure only. So your structure meaning layers. And composition of the, listen carefully, composition of the earth meaning which materials comes under earth. We are having aluminum, we are having iron, magnesium, right? Even magma is also there. There are many different rocks also there, minerals, all comes under composition. And your composition of the atmosphere, gases, right? And particulate matters like dust particles, water vapor, all comes under the composition of the atmosphere. And structure of the atmosphere, tropo, strato, meso, iono. We'll discuss in upcoming class everything. Just but I am giving the meaning. So if you get the question, discuss the structure of the earth, you have to discuss only the layers, inner core, middle mantle, and uppermost crust. If you get the question, discuss the structure of the sun, then you have to discuss the layers of the sun. So sun consists which layers, that you have to discuss. You got the point? So here we'll discuss the structure of the sun in this topic, and in the planet topics we'll discuss the structure of the earth. And that we also call the earth's interior or earth structure. Earth structure meaning earth consists three layers: inner core, middle mantle, and uppermost is crust, right? Okay, listen here, structure of the sun. And structure of the sun consists total 6 layers. Listen first, it consists total 6 layers. It consists total 6 layers, very important. And these 6 layers are classified into 2 groups. So you can write down also. So structure of the sun consists 6 layers. It consists 6 layers. And these 6 layers are classified into 2 groups. One is inner layers and outer layers. Inner layers and outer layers. So inner layers, there are 3 inner layers and there are 3 outer layers. So these 6 layers are classified as inner layers and outer layers. Inner layers are 3, outer layers are 3. And inner layers consist core, radiative zone, and third one is convective zone. And outer layers consist 3 layers. That is photosphere, and second one chromosphere, and sixth one is corona. Sixth one is corona, right? So total 6 layers: core, radiative zone, convective zone. At least you should know. They can ask direct question in the prelims: which of the following are inner layers of the sun? And they can ask the direct question: which of the following are outer layers of the sun? Inner, outer, total 6 layers are there, and that 6 layers we call structure of the sun. Structure of the sun consists 6 layers. So if you just I give the list, you will not understand. Take the diagram, then there will be more. You will get the more clarity, right? Is over. Okay. Listen, next point. Listen first. So here, whenever you get the question, structure of the earth or structure of the sun. So many students will draw this diagram. Listen first, don't write, just listen. So central is core, middle is mantle, outermost is core. And they will show it is a core, it is mantle, and it is crust. It takes more time. To draw all the layers, entire diagram. So instead of drawing this entire diagram, you can draw this small. You can take this. You can draw this much also in exam. So this is core, and this is mantle, and this is crust, right? So here core. This is the core part. If you take the Earth's surface, core, and it is mantle, and it is crust. So these are the 3 layers of Earth's interior. So similarly, so it comes to sun also. You have to draw only 3 layers. So for example, with respect to Earth, just listen. So these 3 are Earth's interior, and Earth outer external part or outer part consists the atmosphere, right? And atmosphere you can draw like this. Just listen. So troposphere, stratosphere, mesosphere, ionosphere, and exosphere, right? Troposphere, stratosphere, and mesosphere, ionosphere, and exosphere. So rather than drawing the entire diagram, if you draw this much also, it will save your time also, it looks good also. And in your answer, because they will give only 2 pages for 150 words question, they will leave only 2 pages. If you draw entire diagram, half of the page will be occupied only by the diagram only. And just to reduce the space and to reduce the time also, so you have to draw the such diagrams, and it looks good also. So if you draw the entire diagram, again it takes more time, and the diagram also will not become good, right? And again you will take the rubber and you will waste a lot of time, right? And also please remember, you draw such a small diagram. If you draw such diagram, small diagram, so that is also correct, right? You have to draw this much only. So such diagram, the small diagrams also gives the entire meaning, complete meaning. So this is related to Earth, but we are discussing here sun, and that 6 layers I will show here. Just take this diagram. And take the diagram on the new page, because it's a very big diagram, and start from the left side, so that we can draw complete till that right part or right end. Start from left side. So this is core, it is radiative zone, it is convective zone, and it is photosphere, it is chromosphere, it is corona. And outer 3 layers, these 3 outer layers and 3 inner layers. right? So 3 inner layers. This is core, and it is radiative zone. Radiative zone. It is convective zone. Convective zone. And it is photosphere. Photosphere. And it is chromosphere. And finally outer one is corona, right? And these 3 outer layers, these 3 are the outer layers, and these 3 are the inner layers. Inner layers and outer layers. So 3 inner layers and 3 outer layers, right? So this is the magnetic field, strong magnetic field, and the radiation starts from this radiative zone. It goes towards the planets like Earth, and Earth consists the outermost magnetic field or magnetosphere. This is the magnetosphere. Magnetosphere, and at the center it is the Earth. Earth. Earth, right? And it is troposphere, stratosphere, mesosphere, ionosphere, and then it is exosphere, right? And magnetosphere is the part of exosphere only. Magnetosphere, magnetosphere, tropostrato, and meso. And just listen. So from the Earth surface, in the north we are having here Arctic region, and in the south we are having the Antarctic region, right? And very colorful, listen, very colorful lights will form in the ionosphere region. Take this diagram properly, very important diagram. Okay, so these colorful lights will form, and these colorful lights are known as auroras. So it is known as aurora borealis, aurora australis, and it is solar winds, and solar flares, solar winds, and just it is sunspots, plages. Just mention this down, we will discuss in detail later everything, but take the diagram properly. And every year one question repeats again from this diagram, very important diagram. Okay, Raja Marthanda, he is asking, sir, explain the theory behind the moon or any satellite fall down. So please control your emotions, right, Raja Marthanda. I will come to that point. So whatever topics I'm taking, just focus it, just follow the topics. I know what to teach, how to teach everything, right? I will cover each and everything. Don't be that much you can say very active and very enthusiastic now in the beginning, but everything I will cover each and everything. After completion of the classes, then you can tell me, sir, this is a topic left like that. But I will not leave a single topic also, don't worry. So I am going in a sequence because I have this sequence, right? So if I randomly pick the topics, no, it is not good, right? And it is not good for you also, not good for me also, right? So just follow the topics which I am discussing here, right? We'll cover each and everything, don't worry. Matanda bhai. Meenakshi saying that, sir, sun has more gravity. Yes, true. Sun has more gravity. That already I explained. Sun having 274 meter per second square. Vivek Kumar saying that, sir, sun is the largest, the hottest, or the biggest and brightest star in our. Yes, true. That is the hottest planet, star, not the planet. Sun is the star, right? And it's the biggest star in our solar system. Correct. Good. Okay. Anything else? Okay. ठीक है. Night. Next point. Have you taken this diagram? Take it first. And online students, if you are not able to take the diagram, just take the screenshot so you can draw it later, no issues, right? For online students, so it's again, there is another one alternative option. You can take the screenshots of the diagrams and you just leave the page, you can take it later after the class. But I am giving sufficient time to take the diagram because diagrams are very important, and without diagram you will not understand the geography. The entire geography is the game of diagrams, right? And that's why each and everything I am explaining with the help of diagrams. Over? Okay, now understand the concept. So this is a diagram. I will explain all the concepts and then later I will dictate the points. First, focus on the concept. Listen here, if you take the earth, so earth, listen first. It is the earth, the central part, it is the core, and middle part is the mantle. It is core, it is mantle, and it is crust, right? I am talking about the earth's structure. And then we are having here troposphere. We are having troposphere, stratosphere, mesosphere, ionosphere, and exosphere, right? Troposphere, stratosphere, mesosphere, ionosphere, and exosphere. And they are all together, we call the atmosphere here, atmosphere of the earth. Listen first, atmosphere of the earth. And this one we call the body of the earth, right? Body of the earth. Body of the earth, listen carefully. So body of the earth, and body of the earth consists 3 layers, core, mantle, and crust. And atmosphere of the earth consists 5 layers, troposphere, stratosphere, mesosphere, ionosphere, and exosphere. And this 5 layer forms the atmosphere of the earth, and this 3 layer forms the body of the earth. So we can see the tropostrato, mesoionosphere, meaning we can see the atmosphere, but we can't see the core, because core is inside the earth, it's a solid part. We can't see the inside part, but we can see the upper atmosphere, right? That's why your atmosphere of the earth is visible one, it's a visible one, but body of the earth is invisible. Please remember, we can't see the core, we can't see mantle, we can't see the crust also. Only surface part we can see, but the crust in the inner part of the crust we can't see, right? That's why your body we can't see. These are the invisible. So body of the earth is invisible, and the upper part is visible. So for same like, so we can see the external features or the morphology of the humans, but we can't see their heart, we can't see their liver, because they are inside, right? We can't see this one, but we can see the face, which is the external one, morphological one, external one, right? So here the center of the earth, this one inside of the earth, it is invisible, but the atmosphere is visible one. So if you get the question, which layers of the earth are visible? Only the external layers or the atmospheric layers are visible. Tropostrato, we can see tropostrato, mesoiono, they are visible one, but it is invisible layer. So similarly, please remember, these 3 layers, core, radiative zone, convective zone, these 3 layers we call inner layers, and that inner layer forms the body of the sun. So these 3 are inner layers. These 3 inner layers, listen carefully. The body of the sun, they are the inner layers of the earth, and they are the outer layers of the earth. So these are the outer layers, and the outer layer forms the atmosphere of the earth, and inner layer forms body of the earth. So similarly, so these 3 layers, core, radiative zone, convective zone, these 3 form the body of the sun, and photosphere, chromosphere, corona, these 3 outer layer forms the atmosphere of the sun. Very important point. So which 3 layer forms atmosphere of the sun? Photosphere, chromosphere, corona. Which 3 layer forms body of the sun? Core, radiative zone, convective zone. And which 3 layers forms body of the earth? Core, mantle, and crust. Which 5 layers forms the atmosphere or the which form the atmosphere of the earth? Tropostrato, mesoiono, exo. They forms atmosphere of the earth, and core, mantle, crust forms body of the earth. Similarly, core, radiative zone, convective zone forms body of the sun, and photosphere, chromosphere, and corona will form the atmosphere of the sun. You got the point? And which layers? Listen carefully. So which layers of the sun are visible? Apply the concept here. Which layers of the sun are visible? Yes, very good. Photosphere, chromosphere, corona, they are visible because they are the atmosphere. We can see that one. And Aditya L1, you might have heard about Aditya L1. It's a mission launched by ISRO for the study of corona, that outer part of the atmosphere of the sun, right? And most of the space agencies, they are launching these satellites for the study of the corona part of the sun, because we can't directly go inside the core, or we can't go inside the radiative zone, right? It's not possible also. It's a very hot object. Sun is very hot object. Even we can't go very close to the sun also. It is very hot object. That's why the satellites will be launched only surrounding to the corona, and they can study the corona part of the sun, right? So here, so outer part is visible, corona is visible, right? But radiative zone is not visible, convective zone is not visible, and core is also not visible. These 3 layer forms body of the sun. These 3 layer forms the atmosphere of the sun. You got this point? So now we'll discuss one by one, very important one. And just once after discussing these, right? Just listen. We're having one more point: sunspot. Sunspots are the cold areas. Sunspots are the cold areas that found in the photosphere. And why they are cold areas? Because the radiation is not traveling. And why the radiation is not traveling? Because of the strong magnetic field. If the strong magnetic field exists, listen carefully. The area where strong magnetic field exists, suppose if the radiation travels here, and if it's a strong magnetic field, the radiation will come back. Radiation will come back and it circulates. It circulates, and again the radiation will reflect and it circulates, right? And if there is a strong magnetic field, the radiation will not travel further, and that's why that surface will remain cold. Because if, for example, just listen carefully. For example, if suppose this is the surface, right? This is the surface, and if the radiation, this is the radiation, and it's a strong magnetic field area, then radiation will not travel, just it reflects and it starts coming down. Again it goes and it reflects and comes down, and that's why this part remains cold. Why it remains cold? Because the radiation not coming out, right? The radiation not coming out, that's this part remains cold. And if suppose the radiation, if suppose this is a weak area, just listen. One minute. Suppose this is it having weak magnetic field, then easily here the radiation will travel from here. Radiation will travel if there is a weak magnetic field, and then this area will become the hot area. This area becomes the hot area, and that hot area is known as plages. This hot area is known as plages. So hot area, this hot region we call plages. This cold region is known as sunspots. The cold region is known as sunspots, right? It is known as sunspot. And the hot region is known as plages. Why it is a hot region? Because the radiation is traveling, the radiation is coming out. And why radiation is coming out? Because of the small magnetic field or weak magnetic field. So your sun is very large. In some area it having strong magnetic field, in some it having the weak magnetic field. The areas where strong magnetic field is existing, the radiation will not travel further, it reflects back. And at it reflects back and it circulates. So that's why it is also known as a convective zone. Convective zone meaning your radiation travels in a convective cell or in a circular path. That's why we call convective layer. And if there is a strong magnetic field, that upper part remains cold, and that cold areas we call sunspot. The cold areas we call sunspot. And if there is a weak magnetic field, that area becomes warm, and that warm areas are known as plages. So plages are the warm areas and sunspots are the cold areas. You got this point? And listen, one more important point. And when the radiation will travel, some of the radiation will reflect back towards the corona, and that we call solar flares. Solar flares meaning when the radiation will go in a huge quantity, some of the radiation will attract it back. The some of the radiation will come back. If suppose I am the sun, if the radiation is going from here, so most of the radiation will go towards the planets, and the some radiation will be attracted back. Some radiation will come back. That we call the solar flares. And when the radiation will eject in a larger quantity, so it is also known as a mass ejection, solar mass ejection. It is also known as solar mass ejection. Solar mass ejection meaning the radiation will travel in a huge quantity, in a large mass, we call solar mass ejection. Solar meaning sun, mass meaning large quantity, ejection meaning releasing or traveling. Solar mass ejection, right? Solar mass ejection, and out of that solar mass ejection, so some of the radiation will travel towards the planets, that we call solar winds. And solar winds meaning it is the stream of, listen first, it is the stream of the charged particles like protons and electrons. It is a stream of charged particles like protons and electrons, and when they travels towards the planets, they're like after crossing the magnetic field, so their color will change, and different colors will form in the ionosphere. Very important point. The different colored light will develop in the ionosphere, because ionosphere consists the ions, and ions plays very significant role in the formation of colorful light. You might be studied about prism in your school days. When the light will pass on the prism, you will find different colors. Same, it acts like a prism. And when these solar winds travel from the magnetic field, so they will form different colors, and that color will be intensified further by the ions. And how many colors will form? 5 colors. So 5 colored light will form. And the 5 colors are red color, green color, blue color, yellow color, and pink color. These 5 colored light will form, and that colored light we call auroras. And recently it is very much in the news, right? Recently many auroras formed in the northern hemisphere, right? And from last 1 week it is very much in the news. If you are reading the newspaper, you might be knowing about auroras and solar winds, right? So many auroras are forming near Arctic region, and near Himalayas also. In the Ladakh also there are many auroras formed. Ladakh, which is high altitude mountain, Ladakh, it also having many auroras. Very important topic, auroras and solar winds. What are the auroras? They are the colorful lights. And how many colors will be there in the auroras? 5 colors. Which are the 5 colors? Red, green, blue, yellow, and the pink color. That colorful light will form, and that colorful light we call auroras. In northern hemisphere they are known as aurora borealis, and in southern hemisphere they are known as aurora australis. And auroras generally will form near Arctic region and Antarctic region, because Arctic and Antarctic region are very cold one. There will be more ions above the Antarctic and Arctic region, and that helps to formation of auroras. If you get the question, so in which part of the earth maximum auroras forms? So answer polar regions. In general, practically Antarctic region in southern hemisphere, Arctic region in the northern hemisphere. And auroras will not form at the ground level. Auroras forms in the ionosphere, because ions also essential for formation of auroras, right? And auroras are known as aurora borealis in northern hemisphere and aurora australis in southern hemisphere. What are the auroras? They are the colorful lights. What is solar wind? It's a stream of a charged particle, protons and electrons. What is solar flares? When the radiation will come out from the sun, right? And some of the radiation will go back towards the corona, and that we call solar flares. And when the radiation comes in a large mass, we call solar mass ejection. What is sunspot? These are the cold areas that develops in the photosphere. What are the plages? These are the hot areas that develops in the photosphere. And what is photosphere? Photosphere is the layer of the sun's atmosphere. What is chromosphere? Chromo meaning color. And chromosphere, it's a very thin layer. It's a very thin layer that found between photosphere and corona. And this chromosphere, it having the burning gases, and that's why it looks the colorful. So colorful meaning not different colors, it looks reddish in color. So because of burning gases. Different hot gases, many hot gases will found in the chromosphere. That's why it will found very hot, right? And if you get the question, what is the temperature? What is the temperature of the this core? The temperature of the core will be around 16 million degrees Celsius. Very important. 16 million degrees Celsius or 1.6 crores degrees Celsius, right? But the temperature of photosphere, listen carefully, temperature of photosphere will be around 6,000 degrees Celsius, and temperature of chromosphere will be around 5,000 degrees Celsius, but temperature of corona is around 4,000, right? But listen, the corona temperature will be 1 million, around 1 million degrees Celsius, and many students will apply their common sense and they will say only 4,000 degrees Celsius. But the temperature of corona will increase because of the solar flares, because solar flares are coming back, and because of the solar flares, because of that reflecting radiation, the temperature rises and the temperature will become 1 million degrees Celsius. So even though corona is very far from the core, because core is very hot, and from the core the temperature goes on decreasing, but the corona temperature is very high because of the solar flares, right? So you got the concept, this one, it's very important concept. Now write down very important points, few points write down. So have you taken the diagram? Sunspot is very good. Sunspot temperature will be around 4,500 degrees Celsius. So it is lesser than the temperature of the chromosphere, right? Okay, write down. So your structure of the sun, and write down one point. First put the heading inner layers of sun, inner layers of sun. Okay, next point write down. So your heading should be inner layers. Okay. So in inner layers, especially listen carefully, inner layers consist 3 layers, and these 3 layers forms body of the sun. Remember this point. Inner layers consist 3 layers. 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 Full stop. These layers forms body of the sun. 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 Full stop. These are invisible layers. Underline the word invisible, very important, and put double star. These are invisible layers. If you get the question, which of the following are invisible layers? So answer is core, radiative zone and convective zone. These are invisible layers. Full stop. Next point. Put the heading core. First put the heading core. Core. Write down. It is innermost. It is innermost layer. It is innermost layer. It is innermost layer of sun. 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 Right? Very important point. It is innermost layer of sun. Full stop. Nuclear fusion. Nuclear fusion reaction takes place in this layer. Nuclear fusion reaction. Nuclear fusion reaction takes place in this layer. Nuclear fusion reaction takes place in this layer. Nuclear fusion reaction takes place in this layer. What is the meaning of nuclear fusion? What is the difference between fusion and fission? Okay, listen. So fusion meaning two atoms joins to form the bigger atom, right? So two atoms will join here. Two atoms will join to form the bigger atom. Two atoms will join to form the bigger atom. Right? So this we call nuclear fusion. Nuclear fusion. If suppose here atom 1 and 2 will join to form atom number 3. Atom number 4 and 5 will join to form atom number 6. And 3 and 6 together forms 7. Listen carefully. So here 1 and 2 forming 3 and 4 and 5 forming 6 and 3 and 6 together forming 7. Among this we are having totally here how many atoms are there? 1, 2, 4 and 6 and 7. We are having 7 atoms. Among 7 which is the largest one? 7, right? Listen. So if suppose your mass of, just I am taking the example, it is 2 gram mass. The mass will be more, just I am taking the example. So it also 2 gram mass, right? It also 2 gram mass. It also 2 gram mass. What could be the mass of 3? Less than 3 or more, mass of the atom number 3. So it is less than 2 gram or more than 2 gram? Mass of 3, listen carefully. So here atom 1 and 2 together forming atom 3. The mass of atom 3 will be less than 2 grams or more than 2 grams? More than 2, right? Because both together they are forming. So atom 1, atom 2 together it forming, right? When 2 atom mixes, the bigger atom is forming, right? But the mass of this atom 3 will be lesser than the 4 gram, because the entire mass will not convert into the another atom. Some losses also will happen, right? Some losses also happen during this process, right? The losses also happen. That's a mass of this 3 will be lesser than the 4 gram, because both together is 4 gram, but entire 4 gram will not convert into the 4 gram object. If there are two small jamuns, if you mix both, it becomes a big jamun, right? The 2 gram jamun, it becomes one big jamun, right? So but here, so when you add two atoms, when it converts into the bigger atom, then the losses will happen. The losses of the mass will take place, right? And that's why always the mass of the larger atom will be lesser than the total mass of the that initial atoms or the atoms which it form it. And mass of 6, listen, mass of atom 6 will be lesser than 4 gram again, right? But now, so your mass of 7 will be lesser than 8 grams, 4 gram. So it also having 4 gram, that's 4 gram. It will be less than 8 gram. It's getting right. So the mass of this object will be less than the 8 gram. So means in the nuclear fusion reaction, the small atoms will fuse. Fuse meaning join. They will fuse and they will form the bigger atom. And the mass of the bigger atom will be it having the mass lesser than the total mass of the atom which forming it, right? So here it's a lesser one. And during this process, remember, I will give an example. So here two hydrogen atoms will fuse to form one helium atom. So two hydrogen atoms will merge or they will join and they will fuse to form one helium atom. And this one we call nuclear fusion reaction. And during this reaction, So huge quantity of heat energy releases. So huge amount of heat energy releases, and with increase in the heat, so here the temperature of the core will be maximum, and the temperature will be around 16. In some places you will find 27 also, 27 million degrees Celsius, but generally we say 16 million. So around 16 to 27 million degrees Celsius will be the temperature of the core. So 16 to 70 meaning 1.6 to 2.7 crores degrees Celsius. And at that temperature, at this temperature, the object will not remain in solid or liquid or gas. They remains in the ionized form. Right? At this temperature, the material, listen carefully, the material in general and the gases in particular, the gases or the material will remain in the ionized form. In the ionized form, and that ionized form of the material we call the plasma state. Plasma state. So in your physics, while studying physics, you might have studied the object will remain mainly in three states: solid state, liquid state, and the gaseous state. And the fourth state of the matter is the plasma state. That plasma state is the ionized form, because when the temperature increases at very huge temperature, the metals will remain in the ionized form. That ionized form of the metal we call the plasma state. One best example for plasma state. So when the circuits, when the electric circuits will happen in the circuits, so there will be some spark. That spark will happen when the huge power will pass us, right? So when the spark occurs, that spark is the best example of the plasma, right? Plasma state. Or the core part of sun, remains in the form of plasma state. It remains in the form of plasma state. So because sun mainly made up of two important material or two important gases, hydrogen and helium. Sun is made up of hydrogen and helium, and these gases mostly remains in the ionized form, and that's why what is the state of the core? Plasma state. Plasma state, very important. Plasma state meaning it's a ionized form of the material, right? So here please remember we are discussing the core, and the nuclear fusion takes place in the core, and in that two atoms of hydrogen will fuse to form the single atom of helium. Just on this point, during nuclear fusion reaction, two atoms of hydrogen joins, or the fusion takes place. Two atoms of hydrogen joins, or fusion takes place, and leads to formation of single helium atom. Leads to formation of single helium atom. Right? Full stop. During this process, huge amount of heat energy releases. Huge amount of heat energy releases. Therefore, core consists maximum temperature. Very important point. Therefore, core consists maximum temperature. Full stop. Temperature of core ranges between 16 to 27 million degrees Celsius. 16 to 27 million degrees Celsius. Temperature of core ranges between 16 to 27 million degrees Celsius. 16 to 27 million degrees Celsius. Right? Full stop. Next point. At this huge temperature, any materials remains in ionized form. ionized form is known as plasma state, 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 right? Full stop. It is the fourth state of the matter. It is the fourth state. State meaning not Telangana state or Andhra state. State meaning the condition or situation, physical state we are talking here. It is the fourth, it's a fourth physical state you can mention. It's the fourth physical state of the matter. Fourth physical state of the matter. Okay. Please tell me, because you might have studied in your school days, which is the only metal that remains in liquid form at room temperature? Which is the only metal that remains in liquid form at room temperature? Yes, very good. Mercury. Mercury. And which is the only object that remains in the gaseous form at room temperature? Answer is bromine. You might have heard about bromine. It remains in the gaseous form at room temperature, and mercury remains in liquid form, even though it's a metal, but remains in the liquid form at room temperature. These are some two exceptional cases. Otherwise, solids, otherwise metals remains in solid form. But it is an exceptional one, mercury, right? Okay, listen. So next point. So this is a nuclear fusion reaction, and in the nuclear fusion reaction, the metals will convert into ions, and that ionized form we call the plasma state. And all these stars having the core, and in the center of the any star, not only sun, you take any star, at the center of these stars, which reaction takes place? Nuclear fusion. And they will confuse you by giving the statement. So nuclear fission reaction takes place at the core of the stars. Wrong statement. Nuclear fission will not take place, nuclear fusion will take place. And when the atomic bombs are spotted, right? So which reaction you will find there? Nuclear fission. In atomic bombs you will find nuclear fission, right? But not the nuclear fusion. Nuclear fusion in the stars, right? And nuclear fission in the atomic bombs, right? So your fission, in fusion meaning, please remember, what happens in the fission? The single larger atom, it splits into two atoms, and the two atoms further splits into two more atoms. It splits into two more atoms, and that further splits into two or more than two also, right? It further splits into two, and that further splits. So like that till its mass decreases. It goes on that you can say friction meaning, splitting meaning, so breaks into smaller pieces, that we call the splitting. So this is a nuclear fission reaction, but in the nuclear fusion, the fusing will take place. The two atoms will join and to form the larger atom. But in fission, larger atom will split into two atoms, that 2 into 4, 4 into 8, 8 into 16, like that. The fission takes place. And fission takes place in atomic bombs, right? When the bombs are blasted, so here you will find the pieces, lot of the pieces, or the crackers, that rocket crackers. When we launch the rocket crackers, you will find lot of the splitting. That is the best example, right? So rocket crackers. So here next point. So nuclear fusion takes place in all the stars. Please remember one more important point. Our Earth also having the core, but nuclear fusion reaction not taking place at the center of the Earth. Just please remember this very important concept. So our Earth having the core, but nuclear fusion reaction is not taking place at the center of at the core of the Earth. Why? What is the reason? And that's why Earth is completely depending on the sun for its heat energy, because Earth don't have its own source of heat energy, right? So because Earth depending on the sun for the radiation, Earth depending on the sun for the light also. So even Earth having the core, but the nuclear fusion reaction will not take place because for nuclear fusion reaction, the minimum required temperature is around 2 million degrees Celsius, or almost more than 1 million degrees Celsius. 1 to 2 million degrees Celsius temperature should be there to take place in nuclear fusion reaction. So at very high temperature only the metals will join or they will fuse. At low temperature the metals will not join. You get my point, right? So when we want to fit or fuse two metals, we have to heat them and we have to convert into liquid, then only they will join. Or generally the two metals will not join, right, in their solid form. So to melt or to mix, to mix two metals, first we have to give the temperature, and at high temperature only they melts, and that liquid only we can mix. So similarly here, So at the center of the earth, the temperature is very less, and that's why nuclear fusion reaction will not take place at the center of the earth. At the center of the earth, we are having just 6000 degrees Celsius temperature, and this temperature is not sufficient to fuse two metals or to fuse different metals. And at 16 million degrees Celsius, right, you take any metal, so they will convert into ionized form, and that ionized form is very essential for that nuclear fusion reaction. If you get the question, so earth also having the core, but why nuclear fusion not taking place? Then answer is the minimum temperature. Just try to note. Notes are again very important point. Whenever I dictate the note, that is also very important for your prelims exam. Note, write down, note. Earth also having core. Earth also having core, but nuclear fusion reaction will not take place. Earth also having core, but nuclear fusion reaction will not take place. Because will not take place because core of the earth having lesser temperature. That is around 6000 degrees Celsius. Core having lesser temperature, that is around 6000 degrees Celsius. Right, full stop. For nuclear fusion reaction, minimum temperature should be 1 to 2 million degrees Celsius. For nuclear fusion reaction, minimum temperature should be 1 to 2 million degrees Celsius. 1 to 2 million degrees Celsius. Right? Okay, full stop. Listen, one more important point. So at the center of the sun or at the center of the star, the hydrogen converts into helium. Listen carefully. So hydrogen converts into helium. If the entire hydrogen converts into helium, just imagine, it's a hypothetical case, a hypothetical study. If the hydrogen of that core part of the stars, if it completely converts into helium, what happens to that star? Sorry? It lifts into the air. Okay. Anyone? Listen, if suppose the vehicles like 4-wheelers or 2-wheelers or 16 or any wheeler vehicle, right? That vehicle will run till the petrol or diesel will be there in the tank. If petrol completes, that vehicle will stop there only. If diesel completes, that vehicle will stop there only, right? The main fuel for the vehicles is the petrol or diesel, or nowadays we are having CNG. That also, CNG also is not like, no, if the CNG completes, again the vehicle will stop, right? CNG vehicles or electric vehicles, the electric vehicles also will stop if the battery comes down. You take anything, nothing is permanent. So your electric vehicles and CNG vehicles are developed just for the environment friendly, because just to reduce the environmental issues or to reduce the environmental pollution, because petrol and diesel vehicles are causing more environmental pollution, right? And to reduce the pollution, environmental pollution, so your electric vehicles and CNG vehicles are introduced. But for electric vehicles, we have to charge the batteries, and without charging they will not run again. So if you take the scooty also, now we are having the electric scooty also, so we have to charge almost 8 hours, I think 6 to 8 hours we have to charge. Then only it will run around 60 or 80 kilometers, right? And if suppose you are going for long trip, in between if the battery goes down, it's very difficult. Then you have to take the scooty, you are along, bhaiya karko, bhaiya ko bolna padega, so bhaiya thoda sa push up karo bhaiya wahan tak, right? And nowadays we are having many petrol and diesel. We are having petrol and diesel because we are having the petrol pumps, but we are not having that electric points, charging points in India right now everywhere, and that's why the electric vehicles are suitable for shorter distances, not for the longer distances. Because everywhere we are having the petrol pumps, like Indian Oil or Reliance or something, we are having the petrol pumps, but we are not having the battery points everywhere. So if we are having the battery points, we would have stopped the vehicle, we would have charged it, and we would have went, right? And again it takes more time. So if suppose we are going for important place, and if you have to stop for 8 hours just only for the charging, it's very difficult, right? And that's why electric vehicles are suitable only for the short distances, not for the long distances. And that's why here, please remember, petrol and diesel vehicles they causes more environmental pollution, right? And CNG and electric vehicles causes lesser pollution. And that's why we are into this one, electric, at least for shorter distances, like mostly for auto rickshaws, because auto rickshaw will not go beyond city. If you take the rickshaws, they will run in the city only, right? And for that, they are, because these electric vehicles and CNG vehicles are suitable within the city, like Ola, Uber, and even that rickshaws, but they are not suitable for the taxis, like from India to from Hyderabad to Kanyakumari, or from Kanyakumari to this one Jammu Kashmir. So we can't take the rickshaw, or we can't take the electric vehicles or the CNG vehicles, or in between वहीं खाना खा के सोना पड़ता है, right? We have to sleep in between the road itself, right? Okay, please remember. So if the hydrogen completes, I give the example, if the fuel completes in the vehicle, that vehicle will stop. That vehicle will become almost dead, right? And again, when you put the fuel only, then only that vehicle will run. Similarly, if the hydrogen completes in the star, hydrogen is the fuel in the stars. If hydrogen completely converts into helium, that star will die. That star will die, and that we call the dead star. Dead star, and there are 3 types of dead star: white dwarf, neutron star, and black hole. Right? These are 3 types of dead stars. So we'll discuss which star we should call as a white dwarf, which star we should call as a neutron star, and which star we should call as a black hole. First, you should know what is dead star. Dead star meaning the star without fuel in its center, or the star without nuclear fusion at its center, we call the dead star. And when the star will become dead, so if the fuel completes at its center, when the fuel completes, that star will stop its life, right? And it is very important topic that even we call the life cycle of the stars. Life cycle of the stars. So the way we call hydrological cycle, the way we call human cycle, they will call rock cycle, the way we call soil cycle, we are even having the star cycle also. For example, hydrological cycle, what is the meaning of hydrological cycle? The water will evaporate from the water bodies. That water will condense, leads to formation of clouds. From the clouds, rainfall occurs. Again, the rainwater comes to the water body like rivers, lakes. Again, the evaporation. Again, cloud formation. Again, rainfall. That is a hydrological cycle. And biological cycle meaning we'll get birth. And again, so after we'll become adult, we'll get marriage, we'll give birth to again children, and we'll die. And that children will give birth to some other children. Like it's a life cycle, right? So here we'll get birth, will grow in the ecosystem, in the environment, right? And will die, again will go to the soil. Because please remember, our body consists different types of minerals, like phosphorus is there, sulfur is there, and even calcium is there, magnesium is there. Our body consists different types of minerals, mainly in the bones and even teeth also, right? And when we die, so the body should be buried in the soil. We should not burn the dead bodies. So because many people don't know the scientific reason. If you burn the dead bodies, what happens? It becomes ash, and that ash will fly in the air. It becomes the pollution also. But what the most of the people will do after burning the body, they will take the ash and they will make to flow in the water, rivers. Most of the people do this one. And rather than doing that one, if you bury the body in the dead bodies of humans or dead bodies of any animals, if you bury in the soil, so that after decomposition, whatever minerals we are having in our body, that minerals will come back to the soil, and the soil get the fertility. That fertility will increase in that particular area. It's very important, but many people don't know this one. So what the people will think, if you bury in the soil, it can become the ghost, it can come because it can again attack also. How come it become ghost? Because we are having lot of superstitious things, lot of superstitious, do you know this one, superstitious things? There are lot of misunderstanding, superstitious things. So many people will believe it, okay, he will become ghost and he will enter in our body, right? That is roaming Atma, that Atma will come to our Atma, he starts doing dances, right? So it will not happen, because educated person, we should understand the reality, right? So when he was alive, he is not able to do anything. After dying, what he will do? Get my point? So when his life is not doing anything, and after death, because after death meaning no meaning. So please remember, so when we are alive, so they will call by our name, like Vilas sir. And after death, where is the dead body? They will not call where is the Vilas sir, where is the Vilas sir body, they will call where is the dead body where is the dead body. So because we'll lose each and everything, our respect will go. So because only till the time, so we are alive, there is a respect to this body. And if our जब life goes, so there is no meaning to this body, there is no respect to this body, so they will call when the dead body is coming from the hospital. And if you go as a life for some treatment, when the Vilas is coming, they will say when the Vilas is coming. And if I die in the hospital, so when the dead body is coming, the name will change. There is no meaning to this. That is life only, right? So that's why here, so life means it's not permanent. It is not stable. It's like a water bubble. It can collapse at any time, right? So there is a lot of uncertainty, right? So we can't say I will survive for 80 years. Very difficult. So we can't say I will survive 100 years. So because ultimately it depends on the nature. So nature is, our life is in the hand of the nature. So whenever the nature says, so because no one expected that COVID-19 will come and it will kill many people. No one expected, but many people died during the COVID-19. So such disease can come in the future and it can take the life also, right? That's why we should not bother about the life. Just we have to focus on the work. So whatever, how many days we will survive, we have to focus on the work. We have to focus on the just sharing and caring the people, right? Rather than just because many people will fight only for the property and the money. So that is not actual required. So the actual requirement, so because life is not permanent. Had the life is permanent, we have to fight for the money and property also. The people will earn the money, and when they dies, no one knows where he kept the money. No one knows what he earned. You are not getting the point? Okay, come to the point here. So when the fuel of the star completes, it will die. It will die, and after death, we call the dead star. And that dead star, there are three types of dead star. First one is white dwarf, second one is neutron star, and third one is black hole. So now we'll discuss, and that entire cycle we call the life cycle of the stars. First listen, so life cycle of stars. So the stars will, they form from the nebula. First listen, from the nebula. So nebula leads to formation of stars. So stars will form from the nebula, and after death, so they can become white dwarf, or neutron star or black bug. Sorry, not black bug. So black hole. So black hole or neutron star or white dwarf. This complete process we call the life cycle of stars. The stars will originate from the nebula or galaxy, you can say. So stars originates from the nebula and they ends their life as a white dwarf or neutron star or black hole. Now very important point. So which star becomes white dwarf? Which star becomes neutron star? Which star becomes black hole? And what is the meaning of white dwarf? What is the meaning of neutron star? What is the meaning of black hole? You should understand, because it's the last UPSC question, neutron star. They asked direct question on the neutron star. And before that, they asked the question on the white dwarf. This very, very important topic. They will ask the question in the prelims, right? So here, what you have written? So here, please remember. So in hydrogen, two atoms of hydrogen will join, and after fusion, it leads to formation of one helium atom. And during this process, huge amount of heat energy releases, and that's why core having maximum temperature. And so how much temperature is there? So 16 to 27 degrees Celsius temperature. And we have discussed, so why the nuclear fusion is not taking place at the core of the earth. That point also we have discussed. Next point, just write down. Just write down. If, or we do one thing, put the heading life cycle of the star. Heading life cycle of the star. Life cycle of the star. Life cycle of the star. So life cycle of the star, right? Just write down one point. Stars generally originates from nebula. Stars generally originates from nebula. Stars generally originates from nebula. Star generally originates from nebula. Full stop. They consist hydrogen fuel at their core. 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 Full stop. If entire hydrogen converts or transforms into helium, if entire hydrogen converts or transforms into helium, that star becomes dead. That star becomes dead. That star becomes dead. That star becomes dead. Right? That star becomes dead. Very important point. That star becomes dead. Dead. Full stop. There are three types of dead stars. There are three types of dead stars. There are three types of dead stars. First one is white dwarf. First one is white dwarf. First one is white dwarf. Second one is neutron star. Neutron star. Neutron star. Third one is black hole. Third one is black hole. So white dwarf, neutron star, and black hole. Black hole. Black hole. Right? Full stop. So now we'll discuss one by one. So like which star becomes white dwarf, which star becomes neutron star, which star becomes black hole. First put the heading white dwarf. First one is white dwarf. White dwarf. Okay, white dwarf. First listen carefully. So white dwarf meaning, write one definition, that takes definition, if star, if mass of a star is less than or equal to the mass of sun star. If mass of a star is less than or equal to the mass of sun star, then that particular star is known as a white dwarf. Then that particular star is known as a white dwarf. Then that particular star is known as a white dwarf. Then that particular star is known as a white dwarf. Okay, listen. If suppose there is one star, right? There is one star. Listen first. It is the first here you can take this meaning of this line, this sentence. The meaning of this sentence is, so your mass of, listen first. So mass of a star, mass of any star. So it should be less than or equal to what are written? Less than or equal to the if mass of a star is less than or equal to the one point. Just one word is missed here. Less than or equal to the 1.44 times the mass of sun. That point, please add this point. 1.44 times the mass of this sun. Mass of this sun, right? So it is known as a white dwarf. Listen, mass of a star should be less than or equal to 1.44 times the mass of the sun. Then it is known as a white dwarf. So here this symbol less than and this symbol it is equal to or less than. So here mass of a star, you take any star, any unknown star, just listen, any unknown star. So its mass should be less than or equal to the 1.44 times the mass of sun. If suppose this is the sun, listen, it's very important concept. It is sun, and this is any unknown star. It's a X star. Just listen, one star, X star. So its mass, if its mass is less than or equal to 1.44 times the mass of the sun, then we call the white dwarf. I will give one practical example. You will understand in a better way. Suppose if mass of sun is 100 kg. Just I am giving example. The mass of sun is very huge. The mass of sun is 2 into 10 to the power of 30 kg. Just I am giving example for your understanding. So mass of sun is 100 kg. So to call as a white dwarf, what should be its mass? To call as a white dwarf, what should be its mass? If the mass of this sun is 100 kg, and we know the equation here. So here if mass of a star is less than or equal to the 1.44 times the mass of the sun, that is mass of the star should be less than or equal to the 1.44 times the mass of the sun, we call white dwarf. So if mass of the sun is 100 kg, then what should be the mass of the star to call as a white dwarf? Sorry, less than or equal to 1.44 kg. Here only, we are having the answer in front of you only. Less than or equal to 1.44 into mass of the sun is given 100 kg, right? 100 kg, and less than or equal to 144 kg. Correct, right? Less than or equal to 144 kg. Here mass of a star should be less than or equal to 144 kg. If mass is 100 kg, means please remember. So here less than or equal to means please remember here mass of, listen carefully, mass of white dwarf can be equal to 144 kg, right? Or mass of white dwarf can be less than 144 kg, and mass of white dwarf, so less than 144 meaning it can be equal to 100 kg also. Okay, get my point? 100 is less than 144 only. So here mass of white dwarf can be less than 140. Less than 140 meaning it can be 140 also, 130 also, 125 also, 110 also, or 100 also. So it's meaning mass of white dwarf, it is mass of sun. Mass of sun is also 100 kg. Mass of sun also 100 kg. Mass of white dwarf can be equal to mass of sun. Mass of white dwarf can be more than the mass of the sun, because mass of the sun is 100 kg, right? And it is less than 144. Less than 144 means it can be 130 also, 140 also. Get my point? Even it can be equal to 144 also. That is the definition. Mass of white dwarf less than or equal to 144 kg. If mass of white dwarf is 144 kg, meaning it is more than mass of the sun. So it's meaning white dwarf can be equal to the mass of the sun. White dwarf can be greater than the sun, or white dwarf can be less than the sun also. So here less than 144 meaning your mass of white dwarf, listen, mass of white dwarf, even it can be 90 kg also, because this 90 kg is less than 144 kg, because white dwarf can be 144 kg or less than that 100 kg, or it can be 90 kg. It's meaning if mass is less than 100 kg meaning, so white dwarf is smaller than sun. If mass of the white dwarf is equal to 100 kg meaning it is almost similar to the sun, and mass of white dwarf it is 144 kg meaning it is more than the mass of the sun. It can be larger than the sun also. You got this point? So white dwarf can be larger than the sun, white dwarf can be equal to the sun, and white dwarf can be smaller than the sun also. But this equation is very important. So mass of the star, you take any star, because there are billion of stars in the universe. The star which having the mass lesser than or equal to 1.44 times the mass of sun, then it is known as a white dwarf, right? And this limit is discovered by famous Indian scientist Subramanian Chandrasekhar. Listen, so this limit studied by a famous Indian scientist Subramanian Chandrasekhar, and that's why it is famously known as a Chandrasekhar limit. It is famously known as a Chandrasekhar limit because it is discovered by Indian scientist Subramanian Chandrasekhar. It is famously known as Chandrasekhar limit. This question came many times, right? So Chandrasekhar limit. So this Chandrasekhar limit is studied by or discovered by a famous Indian scientist Subramanian Chandrasekhar. And Subramanian fixed the limit, and for this study he got the Nobel Prize also. He got the Nobel. No, Nobel Prize, not Bharat Ratna. He got the Nobel Prize for this achievement. He got the Nobel Prize. So he got the Nobel Prize in the year 1983 for this achievement, right? So he got the Nobel Prize for this achievement, and he became the second Indian to get Nobel Prize in physics. So because C.V. Raman was the first person to get Nobel Prize in physics, and C.V. Raman got Nobel Prize for the study of scattering of light, that we also call Raman effect. And for Raman effect, or for the study of scattering of light, very famous Indian scientist C.V. Raman also, right? C.V. Raman, he was the uncle of Subramanian Chandrasekhar only, right? Uncle of Subramanian Chandrasekhar, and both were very famous in the physics. So here CV Raman, Venkata Chandrasekhar Raman, CV Raman, he got Nobel Prize in Physics. He is the first Indian to get Nobel Prize in Physics. But the first Indian to get Nobel Prize is Rabindranath Tagore. Rabindranath Tagore, first Indian to get Nobel Prize. Please remember. So here the first Indian to get Nobel Prize is Rabindranath Tagore. Let's listen. Rabindranath Tagore. So Rabindranath Tagore got Nobel Prize in the year 1930 itself. So in the field of literature, and his literature was Gitanjali, right? Gitanjali. First Indian to get Nobel Prize, Rabindranath Tagore, but he got in literature. And later in 1930, so CV Raman got. And later in 1979, Mother Teresa. And in 1983, Subramanian Chandrasekhar. Right? So here Subramanian Chandrasekhar got in physics, Mother Teresa got in peace, and CV Raman got in physics, and here Rabindranath Tagore got in the literature. If you get the question, so who among the first or who among the following first Indian to get Nobel Prize? Then answer is Rabindranath Tagore. And if they mention the word particularly like physics, who among the following is the first Indian to get Nobel Prize in physics? Then answer is CV Raman. The first Indian to get Nobel Prize in peace, answer Mother Teresa. So Mother Teresa was not she born in other country, but she got the citizenship of India, and that's why India claiming. So she is from India only, right? Because she got the citizenship. After citizenship, they will become part of India only, right? And so first Indian to get Nobel Prize in peace, in the field of peace. And Nobel Prize is given in how many fields or how many areas? Nobel Prize given in 6 areas or 6 fields. What are the 6 fields? Physics, history, geography, environment, art and culture. PCM, what is PCM? Physics, chemistry, medicine 3, and remaining 3 economics, literature and peace, right? Economic, literature and peace 3, and physics, chemistry and medicine. So total 6 fields are there, and among 6 fields, in all the 6 fields, Indian got the Nobel Prize. In economics also, Amartya Sen, you might have heard about Amartya Sen, he got the Nobel Prize in 1998 itself, Amartya Sen. And recently in 2019, so Abhijit Banerjee, he got the Nobel Prize in the field of physics, in the field of economics. And Mother Teresa got in peace. Another person called Kailash Satyarthi, might know about Kailash Satyarthi, he got the Nobel Prize in the field of peace again in 2014. In 2014 got the Nobel Prize, so in the field of peace. Like that, in all the fields, Indian got the Nobel Prize, right? So Indian got the Nobel Prize, and Subramanian Chandrasekhar got Nobel Prize for this study, right? Very, very important point. Write down here, next point. Write down next point. Here the limit 1.44. Here the limit 1.44. Here the limit 1.44. Here the limit 1.44 was discovered by. Here the limit was discovered by a famous Indian scientist. Subramanian Chandrasekhar. Discovered by a famous Indian scientist. Subramanian Chandrasekhar. Right, full stop. Listen carefully. So here they will ask the question, what is Chandrasekhar limit? So Chandrasekhar limit, it is the maximum limit. So below which the stars remains white dwarf, and above which it becomes a neutron star or black hole. It's a maximum unit. Listen carefully. So if you get the question, what is this 1.44? 1.44, this 1.44, it is not the minimum or lower limit, it's upper limit. Listen, 1.44 times the mass of sun. And stars those remains lesser than or equal to 1.44, they only becomes a white dwarf. And stars those are having mass greater than 1.44 times the mass of sun, so that we call neutron star or black hole. We call neutron star if it is 1.44 to 3 times, right? For example, just listen first. If the mass of the star is if it is it is greater than 1.44 times the mass of sun, but less than I will write here one complete equation, just 1 minute. If suppose mass of a star, if it is greater than 1.44 times the mass of sun, but lesser than 3 times the mass of sun, then we call as a neutron star. And to call as a black hole, mass of the star should be greater than 3 times the mass of sun. Its meaning black holes are very, very large object, so they will be at least 3 times greater than the sun, but neutron star will be greater than 1.44 times, but lesser than 3 times the mass of the sun. Means neutron stars are not greater than because they are larger than the sun, but not more than 3 times the sun. They will be lesser than 3 times the sun. But black holes are they are more than 3 times. They can 4 times also, even they can 100 times greater also. There are many black holes, so they are very bigger than the sun also, right? So here please remember this 1.44. It is the upper limit. So below which the star we call white dwarf, and above which we can call as a neutron star or black hole, right? More than 1.44, it is black hole or neutron star. We call black hole only if the limit is more than 3 times the mass of sun, and we call neutron star if it is less than 3 times and more than 1.44. You got this point? So this we will discuss later after the break, but write on one line, last line, right? So here 1.44 is the upper limit. 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 Right? Very important point. Upper limit. Below which it's upper limit. Below which the stars. Below which the stars are known as white dwarfs. Below which the stars are known as white dwarfs. Right? Very important. Underline the word upper limit. Right? So just write down upper limit. Underline the word upper limit. Right? Okay. Daily geography class will be there or any other subjects. So Hemant Bepula, daily geography classes will be there, right? Don't worry. Till completion of this syllabus, the geography class will be there on the daily basis. Otherwise, so if you give the breaks, we will not understand also, right? So there will be daily classes, at least for because the class will be daily basis. Don't worry, right? So difference between the aurora borealis and aurora australis, right? I will explain. I will complete because just we are discussing the core part. I will come to that point. Don't worry. So I will discuss what is the difference between these two. I will come to that point after the break. Don't worry. Sir, how the layers of the sun are discovered? So your layer, they are because it's a hypothetical study, because we can't directly go inside the sun to measure which layer is there. It's a hypothetical study, and that's why there are many missions also there, right? So here there are a lot of missions launched by the different space agencies just for the study for these layers. It's a hypothetical study, right? Hemant Repula. Next one is, sir, difference between aurora. That I will discuss that point. So after the break, don't worry, right? Okay, so we'll take a lunch break now, and after the lunch break, we'll take the second session. So next class will be from 4 p.m. 2 p.m. to 4 p.m. You take a lunch break till 2 p.m. and please come on sharp time. Don't do because I have to announce one very important point. Please be disciplined, right? Be punctual, because you are going to become the district commissioner, right? The entire district will be in your hand. So if you come on time, the people, those will work under you, they will be more sincere, because they will follow you, because they will say that our boss is coming on the time, so that we should be on time. And if you come late, then they will also take you lightly. They will not respect also. What they say, well, he is not punctual, right? He is not having discipline, like that they will say. So please be on time, right? Whether online students or offline students. So class timing is 11 a.m. meaning you should be inside the class before 11 a.m. So 11 a.m. should be my entry. That is my last entry, right? And please be on time, right? So because suppose if I start I will not wait for anyone. I will start the class on time. And if you lose, so it is problem for you people only, right? Anyway, you are coming for the class, just come 5 minutes early, right? So come 5 minutes early and sit here and just have the 5 minutes, just keep silently. So then your mind will become calm. If you come by running and if you attend the classes, your mind will not work. So come 5 minutes early and just take the rest 5 minutes, and when the classes will start, you will enjoy the classes, right? Online students and offline students, all online students, you have to register 5 minutes before the class timing. If the class timing is 2 p.m., you have to register, you have to log in the class, or you have to attend the class just 2 to 3 minutes before the class timing. And the morning session, the first session is at 11 a.m. So you should be inside the class before 11. Around 10:55 or 10:58, you should be inside the class, right? It's a request, right? Okay. So we'll take a lunch break now and we'll start the class from 2 p.m. right? Thank you. Thank you. Bye bye.